So we discussed about K in physics, what is work done, Hania? What is the only condition that we need is that work is said to be done only and if only the direction is or the distance covered is in the direction of applied force. If it's so, work it would be considered as work is done in physics. If not, तो फिर obviously वो no work done in physics. Work done की equations हम लोगों ने last time भी कर लिए हुए थे. कौन कौन सी work done की equations है हमारे पास? How many equations do we have? एक simple FD, दूसरा mgh, and third one is 1/2 mv square. All of these are connected in a way that if I write, can you see this color? Is it visible? Okay. तो इसके अंदर आपके पास बेसिकली हो क्या रहा है? What we are doing is कि basic equation the work is equals to FD is here. ठीक है? Second was कि if we are saying कि whenever work is done, there is some displacement. So must be some kind of change of energy would also occur. For example, it could be change in the kinetic energy or it could be a change in the potential energy. Okay? It's always the change that we discuss whenever work is done on an object. Why do we consider always a change, Ania? Why don't we say it's equal to kinetic energy? Why we say it's equal to change of kinetic energy? No. Samya, any input onto this? Why do we say work is equals to change of energy, Zawar? Can anyone at least use their common sense for just like 1 second? We just discussed that whenever force is applied, it should cover some distance in the direction of applied force. Okay? So if it's already moving after the application of force, there must be change in velocity. If it's moving, so kinetic energy ka change would be considered. Okay, what change that work has brought into it. And if it's in a state of rest and I've moved it to some certain height, obviously I've changed the height of it, so I've changed the potential energy. Conveyance के भी बात नहीं करें, that's a long topic कि कैसे energy convert हो रही है. We are only focusing on the major section. Why do we consider work done to be changed in kinetic energy and potential energy? Energy conveyance तो एक लंबा topic है. Work apply किया, chemical potential energy has to convert it into kinetic energy, so forth and so on, whatever the thing is going on. So as you could see in the table, they have said that by pushing a car, it does not, but no energy is transferred because your force does not move it. वही जो हमने कहा था, if we are sitting in a car with the engine start, if it's not moving, there is no work done in that. So no, multiple examples. Reading an essay हो गया, the moon orbiting the earth. Why do we consider this as no work done? And there is another important thing. Zawar? No. Whenever an object is moving in a circle, where does the resultant force and acceleration x? Always towards the center, and displacement is across the circle. So they are not in the same direction. Okay? So there is no work done. See, if this is the moon, if this is the orbiting section, the force is in this direction, but the displacement is in this direction. So they are not in the same direction. That is why no work is done. It's still moving. ठीक है? Displacement भी हो रहा है, force भी apply हो रहा है, सब कुछ हो रहा है, but I'm still saying it's no work done. Because in physics, a work is only said to be done if it covers distance in the direction of applied force. Since the force is acting towards the center, the displacement is along the circle. So no work is said to be. Also, we have done the equation that work done is equals to FD cos of theta. Okay? And cos of 90 give us 0. Okay? So if force is towards the center and displacement is like this at 90 degrees to each other. So angle kya bana? 90. So FD cos of 90 would give us an answer of 0 work done. ठीक है. And also let's revise that section. Whenever there is a cos angle with an equation, it means it's a scalar quantity, and whenever there is a sine angle, it's always a vector quantity. Also, if there's a dot between two quantities, it means it's a scalar quantity. And if it's a cross between two although in our book they have not given attention to this detail कि dot and cross का meaning different होता है in physics actually. When you go into the higher classes, you will study about that there's a difference between a dot and a cross. जैसे magnetic field में dot and cross का meaning था ना, इस तरह vectors and scalars में भी dot and cross का meaning है. यहाँ पे उन्होंने interchangeably use किया हुआ है, मतलब they have not paid attention to this detail कि we need to take this that into account that whenever there's a dot between the two quantities, those two quantities are vector in nature. Force and displacement both are vector in nature, but the resultant is 0. And why it's 0? Because the angle between them is 0. Okay. Moving on, calculating the work done. बच्चों वाला काम O levels में बहुत दफा किया हुआ है. Work is equals to FD. उनके कंपोनेंट्स कौन से एक्टिव होते हैं वो भी मैंने आपको डिटेल में बता दिया हुआ था. F cos of theta और D cos of theta are always the active component in the equations. ठीक है. So FD cos of theta and FD sin of theta. Units we do not need to get into detail of that much. ये मैंने आपको O levels में भी बहुत दफा बताया था. F50 का 50 किस में यूज करेंगे एंड MJs में क्या यूज करेंगे 13. ये वही O levels का कॉन्सेप्ट है. राइट. ये वो वर्क डन की एग्जांपल यहाँ पे डिटेल में डिस्कस हुआ. ठीक है. यू कैन रिव्यू दैट ओनली. If you split this tension into X and Y component, you could see that active component is cos of theta. Sin of theta is in the opposite direction of weight, so it would cancel out each other. Displacement is already in the X direction, so D cos of theta will be considered for that. It's the force equation और वो gravitational potential energy हम लोगों ने देखा हुआ है. It's equals to mgh and kinetic energy. अच्छा, इसकी derivation, do you guys want to do a derivation of kinetic energy? Okay, let's do it, even if you don't agree to this one. Remember the equation of motion? 2as is equals to vf square minus vi square. Let's replace s with d to show the displacement of the vector. ठीक है. From here a किसके इक्वल आ जाएगा d किसके इक्वल आ जाएगा 1/2a into vf square minus vi square. We know the equation is equals to f is equals to ma. Okay, just keep these equations in your mind. We know work is said to be done as is equals to fd. I put f as ma and a as यहाँ पे क्या आ जाएगा, सॉरी a की वैल्यू पुट करनी थी m, और a की जगह पे क्या आ जाएगा 1/2d vf square minus vi square, और ये d साथ में as it is आ जाएगा. This would be cancelled out with each other. 1/2 mvf minus mvi square की इक्वेशन यहाँ से आ जाएगी. I repeat, w is equals to fd, f is equals to ma, and a is equals to 1/2d vf square minus vi square. ठीक है. Putting everything into this equation, d got cancels out with 1/2 mv square and mvf square. ट्रांसफॉर्मेशन एंड जो ट्रांसफॉर्मेशन ऑफ एनर्जीज आप लोगों को ये फेमिलियर विद ट्रांसफॉर्मेशन ऑफ एनर्जी का. फॉर एग्जांपल यहाँ से ग्रेविटेशनल पोटेंशियल एनर्जी एट दिस पॉइंट इज 0, एंड जब दिस ग्रेविटेशनल पोटेंशियल यहाँ से काइनेटिक एनर्जी किस में कन्वर्ट हो रही है जीपी में. मैक्सिमम हाइट पे कौन सी एनर्जी होगी जीपी. काइनेटिक एनर्जी क्या होगी 0. व्हाई द काइनेटिक एनर्जी वुड बी 0? Because at maximum height the velocity becomes 0. Then again gravitational potential would start to convert into kinetic energy, and then वो जो है this will keep on going energy conversion from potential energy to kinetic energy. ये you guys are also familiar with this one. पेंडुलम की इक्वेशन भी क्या था कि kinetic energy कहाँ पे maximum होती है at the mean positions, and potential energies कहाँ पे maximum होती है at the extreme positions, and they keeps on converting from kinetic into potential energy, and at the same time, some of it is being converted into the work done against friction. So all of that needs to be keep into account. You guys remember the equation ना? ये कब use करते हैं? mg is equal to 1/2 mv square. When there is no resistive effect present. जब resistive effect present होंगे तो minus fd आएगा साथ में. ठीक है? They might have mentioned that equation here as well. Efficiency, it's the same as we have done in O levels, which is useful output over input into 100. Power की equations W over T and P is equals to FV दोनों हम लोगों ने की नहीं है. Power again is a scalar quantity, तो उसके साथ if we need to use a component तो वो कौन सा आएगा उसका? F cos of theta. This is the equation that we discussed. K distance के equal होता है, इन्होंने दूसरी तरीके से किया हुआ velocity into time के, ठीक है? And when you divide work done with the time, तो time से cancel हो जाएगा, F into V हो जाएगा, and we have this one. Human power, horsepower पता होना चाहिए, 1 horsepower is equal to 746 watts की equal होता है हमारे पास, and average power for human is 116 watts. As I said you in the beginning of A levels that in the मतलब as you will go or progress in your chapters ना, जो estimations है वो आते रहेंगे साथ साथ में, so you will have an idea कि किस तरीके से करना है. Okay, that was step number 5. The power and energy transfers. Let's see it from the other book as well. वो आएगा बाद में. So being displacement a vector quantity ने यहाँ पे एक additional point किया हुआ है कि whenever you change the direction of displacement, you would add a negative sign with that. Because it's a vector quantity, whenever you change the direction of a vector, it should be mentioned with with that of the negative sign. F ये उन्होंने यहाँ से उसी का description बताया हुआ है कि F का cos component is this one. This would be the cos component, and this would be the sine component. So the one which is in the direction of displacement would be considered, would be the reason for the work to be done. तो यहाँ पे उन्होंने उसको discuss किया हुआ है यहाँ पे. Again, energy, an object to do work must have an energy. Two types of energies है हमारे पास. ये एक table बना हुआ है. That is the energy present into the in the nuclei of an atom. तो ये उसका section है. एनर्जी कन्वर्जन एंड कंजर्वेशन, ग्रेविटेशन पोटेंशियल एनर्जी की कुछ डेफिनेशन यहाँ पे डिस्कस्ड हैं. यू कुड रिव्यू इट, वो एक दफा दोबारा से, इट वुड हेल्प यू आउट. थर्मल एनर्जी क्या होती है? एनर्जी ट्रांसफर ड्यू टू द डिफरेंस ऑफ टेम्परेचर. केमिकल पोटेंशियल एनर्जी क्या होती है? ड्यू टू दी एटम्स की वजह से जो होती है, अरेंजमेंट ऑफ एटम्स की वजह से जो होती है. और एनर्जी रिलीज ड्यूरिंग केमिकल रिएक्शन. इंटरनल एनर्जी, सम ऑफ ऑल फॉर्म्स ऑफ एनर्जीज इन अ सिस्टम. Electromagnetic radiation from the sun is the solar energy. Electromagnetic radiation is the energy associated with the waves in the electromagnetic spectrum. Electromagnetic spectrum में कौन से आते थे? Radio waves, microwaves, infrared rays, visible light, UV, X-ray and gamma rays. So उसकी radiations में electric potential energy, energy due to position of charge in an electric field जो हमारे पास होता है, that's something जो पहले हमारे syllabus में होता था, electric field बिल्कुल ही निकल चुका हुआ है. Elastic potential energy, compressors स्प्रिंग में काइनेटिक एनर्जी मोशन की वजह से, एंड ड्यू टू ग्रेविटी ऑफ द ऑब्जेक्ट जो एनर्जी स्टोर होती है, दैट इज अ ग्रेविटेशन पोटेंशियल एनर्जी. एफिशिएंसी अगेन यूजफुल आउटपुट ओवर इनपुट. आउटपुट वुड ऑलवेज बी लेस देन द इनपुट, एंड द एफिशिएंसी कुड नेवर बी ग्रेटर देन 1, बिकॉज 100 से कभी भी ज्यादा वैल्यू नहीं हो सकती है. पावर, वर्क डन, cos of theta, Fv, we have discussed in the previous section as well. The energies, their respective formulas, their derivations, we have discussed it. They have used the equation that I showed you here, 1/2 mv. That's how it's equal to that. Let's review उन्होंने कैसे किया हुआ. F equals to ma, उन्होंने a की जगह पे f over m की वैल्यू पुट कर दी है. ठीक है, सो एस एस से कैंसिल आउट हो जाएगा, हमारे पास यहाँ पे वीज को एक तरफ ले गए, ये इधर जाके मल्टीप्लाई, क्योंकि एलसीएम जब आप लोगे इसका, ठीक है, तो एलसीएम दोनों तरफ आ जाएगा। बट स्टॉप वन, तो this mass will be multiplied with this and this as well. रीअरेंज किया इक्वेशन को, 2 को यहाँ पे लाके डिवाइड किया, ये वर्क डन हो गया, और ये चेंज ऑफ काइनेटिक एनर्जी। तो चॉइस इज योर्स कि आपने किस चीज, नॉर्मली A2 के अंदर ये सब कुछ चीजें आती हैं, उसके अलावा इसमें नहीं आता। इफ वी गो टू द मोमेंटम दैट वी वर टॉकिंग अबाउट, मोमेंटम हमारे पास क्या है, इट इज अ प्रॉपर्टी ऑफ अ बॉडी ड्यू टू द मोशन ऑफ एन ऑब्जेक्ट, ठीक है। वी विल रिज्यूम फ्रॉम हियर in the next lecture.